Okay, we are going to start those examples. Here we go. Put it on the right page. And so we're going to do example 2.3, make this a little bit bigger, and example 2.4. So example 2.3, it says a bicycle moves from rest, that's important, to 5 meters per second in 5 seconds. What was the acceleration? Okay, so fortunately it says what is the acceleration, and we look through our equations and we say, okay, we've got one of those equations for acceleration right there. All right, so final velocity minus initial velocity. So what's our final velocity in this situation? Well, it's the 5. What's our initial velocity? It says that it started at rest, so that means that this would be 0 meters per second. And our time is 5 seconds. So whenever we go to do this, we have 5 meters per second minus 0 divided by 5, which is just 1 meter per second, or you can say 1 meter per second squared. Okay, and that's kind of what I did on the last one where I converted it. I did something kilometers per hour squared, and they had done it kilometers per hour per second, so that's why the number was different. But this meters per second squared, that is the standard unit for acceleration, and that's what you need to be able to remember as far as units are concerned for that. All right, so now let's look at example 2.4 really quick. So this is a good example because it kind of makes you think about it a little bit different. It says that an automobile uniformly accelerates from rest, so you've got that rest again, which basically just means 0 meters per second, at 5 meters per second squared for 6 seconds. What is the final velocity? All right, so this isn't asking us to find acceleration. This is asking us to find final velocity, so that is a little bit trickier. So let's see what we've got here. It says that it started from rest, so what does that 0 meters per second mean? Well, it means initial velocity. And I just told you, what does meters per second squared mean? It means acceleration. Okay, so whenever you see meters per second squared, that's an acceleration unit. And then of course seconds is just a unit for time. All right, so now let's go back to our equation. Well, crud, we have to actually rearrange this equation in order to find final velocity. So how do we do that? Well, we're gonna have to do some algebra. So if I want to get rid of this time on the bottom here, I'm going to have to multiply it to both sides. So right now I have time times acceleration is equal to final velocity minus initial velocity. So how do I get final velocity by itself if this is subtracting initial velocity over here? Well, you just add initial velocity to the other side. So now I have time times acceleration plus initial velocity is equal to final velocity. So I've got 6 seconds times 5 meters per second squared plus 0 is equal to 30. Now, what is my unit? I was looking for final velocity. Well, let me just pull out these units for a minute. I'm going to pull out this unit and this unit. So I've got seconds, and if I was going to ask you to make like a 2 into a fraction, how would you make 2 into a fraction? You just put it over 1, right? 2 over 1 is 2 still. So if I wanted to put seconds as a fraction, I could just put seconds over 1. Okay, that's being multiplied by meters per second squared. All right, so what's going to happen to one of these seconds here? this second and that second is going to cancel. And I'm going to be left with meters per second. So my unit here is meters per second, which is good because that is a unit for velocity. All right, so that's kind of like one of the trickier things in this chapter is rearranging this equation, because I can't put it into a triangle. I can't do a shortcut. I actually have to do a little bit of algebra. All right, so I've done the algebra for you. So you should be able to do an example, you know, like on the homework and stuff. All right, let's see here. All right, now I had told you that we were going to do, that there was another example that was using this equation that shows you how to find average velocity. And it does it by doing the final velocity plus the initial velocity divided by 2. Okay? We know we've done this one already, where we've had speed or velocity is equal to distance divided by time. All right, so what if we are given a question, like in example 2.5 here, that doesn't have a distance? So for example, it says an automobile moving at 25 meters per second. So it was already moving at 25 meters per second. So what is that? That's the initial velocity. Comes to a stop. So it stops. That's our final velocity in 10 seconds. That's our time. And it wants us to figure out how far. Okay, so basically it's wanting us to find out how much distance it goes before it stops. Okay, so how are we going to do this? Well, are we given an initial velocity and a final velocity? We are, right? And we're also given a time. So I'm going to actually rearrange this equation right here, this second equation, to solve for distance. Now this is one of those that you could put into a triangle. So if I was to put this into a triangle really quick. Okay, distance is equal to velocity times time. All right, or you could just do that algebraically if you prefer. All right, but do I have the average velocity here? No, I have 25 meters per second and I have 0 meters per second. So what I'm going to have to do is I'm going to have to use that equation right there and figure out what the average velocity is first. So I have a final velocity, which was 0. I have an initial velocity, which is 25. If I take that and divide by 2, then I'm going to get, what, 12.5? Okay, so then I'm going to take that 12.5 meters per second and I'm going to multiply it by 10 seconds. Okay, so what I did is I took this right here, which gives me average velocity. So this right here, this answer right here, this 12.5 is average velocity times time, which is that 10 seconds. So when I multiply those two things together, I get 125. What happens to my seconds here? They cancel, and I'm left with meters. So I have 125 meters. Okay? Hopefully that makes some sense. Okay. Example 2.6. This says, what was the deceleration of the automobile? So this is actually asking you to find acceleration. So remember, acceleration, deceleration it's the same thing, sort of. I mean, obviously one is getting faster, one's getting slower, but it's still considered acceleration. Okay, so what was our final velocity in that previous example? Well, it was 0. and our initial velocity was 25. You divide that by the time that it took to stop, and it took 10 seconds. So if you take 0 minus 25 divided by 10, you get negative 2.5 meters per second squared. Okay, so that is telling you that it's slowing down, essentially. Okay? All right. If you have any questions on this video, or any of the videos really, just refer to the video number or the name, and we can definitely pick out, wherever you're having the confusion. Okay, I'm going to stop the video here before I start forces, and we will pick up on forces.